The vastness of deep time. The cosmos stretches beyond comprehension, a tapestry of matter, energy, and time woven across scales that dwarf human experience. To contemplate deep time is to trace the universe from its incandescent origins to its distant, silent future. This journey offers perspective, a quiet anchor in the immensity of existence. It invites reflection on the forces that shaped the stars, the galaxies, and the delicate conditions for life. The story of the cosmos is not one of drama or urgency, but of patient unfolding, where moments span eons and silence holds as much weight as creation. This narrative follows the arc of cosmic evolution, from the first sparks of matter to the final stillness, a meditation on the universe's vast, unhurried rhythm. The first light of existence. In the beginning, there was no form, only an infinitely dense point of potential. Approximately 13.8 billion years ago, the universe emerged in the Big Bang, a singular event where space, time, and energy came into being. This was not an explosion into space, but the expansion of space itself. Within the first fraction of a second, the universe grew from smaller than a proton to a vast, seething expanse. The temperature was unimaginable, far beyond the heat of any star, a cauldron of pure energy where matter could not yet hold. As the universe expanded, it cooled. In the first moments, fundamental forces separated: gravity, electromagnetism, and the nuclear forces that bind atoms. Quarks, the building blocks of matter, swirled in a plasma too hot for structure. By 1 second after the Big Bang, the universe had cooled enough for quarks to combine, forming protons and neutrons. These were the seeds of all future matter, the precursors to atoms. For nearly 380,000 years, the cosmos remained a glowing fog, a plasma of charged particles opaque to light. Then came the era of recombination. Electrons joined protons to form the first neutral atoms, mostly hydrogen and helium. This allowed light to travel freely, a moment known as the cosmic microwave background, a faint echo still detectable today. The universe was vast, dark, and nearly featureless, filled with diffuse gas and the first whispers of structure. Gravity, patient and relentless, began to draw matter together, setting the stage for the formation of the first stars. The early universe was a place of simplicity. Hydrogen and helium, with traces of lithium, were the only elements. No planets, no life, no complexity existed. Yet within this simplicity lay the potential for all that would follow. The cosmos was a canvas, its first strokes painted in light and gravity, waiting for the slow work of time to shape it further. Close your eyes now and imagine the universe as a vast, glowing sea, cooling into darkness, with the first atoms forming like delicate threads in an endless void. The forging of stars. As the universe aged, gravity sculpted its formless expanse. By roughly 100 million years after the Big Bang, clouds of hydrogen and helium began to collapse under their own weight. These clouds, vast beyond measure, were the nurseries of the first stars. As they contracted, their cores grew dense and hot, igniting nuclear fusion. The first stars, known as Population 3 stars, were born, massive and brilliant, burning with a ferocity unmatched by later generations. These stars were unlike those we see today. Composed almost entirely of hydrogen and helium, they lacked heavier elements. Their immense size meant they burned quickly, some lasting only a few million years. Within their cores, Hydrogen fused into helium, and helium into heavier elements like carbon, oxygen, and iron. When these stars reached the end of their lives, they erupted in supernovae, explosions so powerful they outshone entire galaxies. These cataclysms scattered the first heavy elements across the cosmos, seeding the universe with the materials needed for planets and life. The remnants of these stars mixed with surrounding gas, forming new clouds. Over time, these clouds gave rise to the second generation of stars, less massive and longer-lived. Some of these stars still shine today, ancient relics of the early universe. As star formation continued, the cosmos grew brighter, its darkness pierced by countless points of light. The process was slow, unfolding over hundreds of millions of years as gravity gathered matter into ever larger structures. Galaxies took shape within a cosmic web, a network of filaments, sheets, and voids. Dense regions of matter formed the threads of this web, while vast empty spaces stretched between them. Galaxies clustered along these filaments, drawn together by gravity. Over billions of years, they merged, forming larger and more structured systems. The Milky Way, our own galaxy, began to form during this time, a barred spiral galaxy that would eventually host our Sun. Within galaxies, stars continued their cycle of birth and death. Supernova enriched the interstellar medium with heavier elements, enabling the formation of more complex stars and, eventually, planets. Black holes, born from the collapse of massive stars, grew at the hearts of galaxies. These supermassive black holes, some billions of times the mass of the Sun, became anchors for galactic structure, influencing the motion of stars and gas. The first stars were not alone for long. As their light ionized the surrounding gas, the universe transitioned from a dark, neutral state to one filled with glowing plasma. This era, called reionization, marked a turning point. The cosmos was no longer a featureless void, but a place of growing complexity, where the seeds of galaxies were taking root. Close your eyes now and imagine the first stars igniting, their brilliant light cutting through the cosmic dark, scattering the building blocks of worlds across the void. The rise of galaxies. By 1 billion years after the Big Bang, the universe was organizing itself into vast structures. Gravity pulled stars and gas clouds together, forming the first galaxies. These were not the majestic spirals or ellipticals of today, but irregular, chaotic clumps, merging and colliding as they grew. Within these early galaxies, star formation surged, fueled by abundant gas. The universe was a place of constant creation, its darkness increasingly filled with light. The universe was now a dynamic place, filled with galaxies of every shape and size. Some were bright with new stars, others dim and ancient. The cosmic web continued to evolve, its filaments growing denser as gravity worked tirelessly. This was the era when the universe began to resemble the one we know, a vast tapestry of light and matter, shaped by the interplay of forces over immense timescales. Close your eyes now and imagine a cosmic web stretching across the void, galaxies glowing like beads of light along its threads, each a world of stars and possibilities. The birth of solar systems. As galaxies matured, the conditions for solar systems emerged. By roughly 5 billion years after the Big Bang, star formation had settled into a steady rhythm. Within galaxies like the Milky Way, clouds of gas and dust, enriched with heavy elements, collapsed to form new stars. Around these stars, disks of material coalesced, giving rise to planets, moons, and other bodies. Our own solar system formed about 4.6 billion years ago. A cloud of gas and dust, perhaps disturbed by a nearby supernova, began to collapse. At its center, the sun ignited, a modest star burning steadily with the fusion of hydrogen. In the surrounding disk, particles collided and stuck together, forming planetesimals. Over millions of years, these grew into planets, from rocky worlds like Earth to gas giants like Jupiter. The early solar system was a violent place. Collisions were frequent, shaping the planets we know today. Earth's moon likely formed from a massive impact when a Mars-sized body struck the young Earth, ejecting material that coalesced into a lunar companion. Over time, the solar system stabilized, its planets settling into orderly orbits. Water, delivered by comets or locked in the planet's crust, began to pool on Earth's surface, setting the stage for life. Across the galaxy, countless other solar systems formed in similar ways. Some hosted planets with conditions suitable for life, though whether life emerged elsewhere remains unknown. The universe, now billions of years old, was a place of diversity, with stars of every type orbited by worlds of rock, ice, and gas. The cosmos had grown from a simple sea of gas to a complex hierarchy of structures, each governed by the same fundamental forces. Close your eyes now and imagine a young star surrounded by a swirling disk. Planets forming like grains of sand gathering into worlds, orbiting in the quiet vastness. The epoch of life. On Earth, life appeared roughly 3.8 billion years ago, though its exact origins remain a mystery. Simple microbes, thriving in the oceans, marked the beginning of a new chapter in the cosmos. Over billions of years, these organisms evolved, driven by natural selection and chance. Life diversified, from single-celled creatures to complex forms that colonized land, sea, and air. The rise of oxygen, produced by photosynthetic organisms, reshaped Earth's atmosphere, enabling new forms of life. The story of life is not unique to Earth in principle, but it is the only example known. The universe contains countless planets, many within the habitable zones of their stars, where liquid water might exist. The chemistry of life, based on carbon and water, is built from elements forged in stars, suggesting that the potential for life is woven into the fabric of the cosmos. Yet, the silence of the universe, with no confirmed signals from other civilizations, suggests that complex life may be rare. Life on Earth has endured through cataclysms, mass extinctions, ice ages, and asteroid impacts. Each event reshaped the planet, allowing new forms to emerge. The rise of intelligence, culminating in humans, is a recent development, a fleeting moment in cosmic time. Intelligence has allowed the study of the universe itself, a recursive act where the cosmos contemplates its own existence through the minds of its inhabitants. The epoch of life is a brief chapter in deep time, yet it carries profound significance. It represents the universe achieving a form of self-awareness, a fleeting spark in the vast darkness. Whether this spark is unique or one of many remains a question for future exploration. Close your eyes now and imagine a planet bathed in starlight, its oceans teeming with life, a fragile thread of complexity woven into the cosmic tapestry. The future of stars. The universe, now 13.8 billion years old, is in its stellar epoch, a time dominated by star formation and galactic evolution. Yet this era is finite. Stars require gas to form, and the supply is not infinite. Over the next few trillion years, galaxies will exhaust their gas reserves and star formation will slow. The brightest, most massive stars will die first, exploding as supernovae or collapsing into black holes. Smaller stars, like the Sun, will endure longer, burning steadily for billions of years. The Sun itself will follow a predictable path. In roughly 5 billion years, it will exhaust its hydrogen fuel and swell into a red giant, engulfing the inner planets, including Earth. Eventually, it will shed its outer layers, leaving a white dwarf, a dense remnant that will glow faintly for trillions of years. Most stars in the galaxy will share this fate, fading into white dwarfs, neutron stars, or black holes. As star formation declines, galaxies will grow dimmer. Mergers will continue, reshaping galaxies into larger, more diffuse structures. The Milky Way is expected to collide with the Andromeda Galaxy in about 4 billion years, forming a single elliptical galaxy. Over time, these galaxies will lose stars to intergalactic space, ejected by gravitational interactions. The universe will become a sparser place, its light fading as the stellar epoch draws to a close. The future of the cosmos is one of gradual dimming as the fires of creation burn out. Yet even in this fading, the universe will remain active, shaped by forces that operate on timescales beyond imagination. Close your eyes now and imagine a galaxy slowly dimming, its stars winking out one by one, leaving only the faint glow of remnants in an endless night. The era of black holes. As stars fade, black holes will dominate the universe. Over trillions of years, most matter will either be locked in stellar remnants or consumed by black holes. These objects, formed from the collapse of massive stars or the merging of galaxies, will grow by accreting matter and merging with one another. Supermassive black holes, already present at the centers of galaxies, will become the primary structures in the cosmos. Black holes are not eternal. Through a process called Hawking radiation, they slowly lose mass, emitting particles over immense timescales. For a black hole with the mass of the Sun, this process would take roughly 10 to the 67 years, far longer than the current age of the universe. Supermassive black holes, with masses billions of times greater, would endure even longer, persisting for 10 to the 100 years or more. During this era, the universe will be a dark, sparse place. Galaxies will have dissolved, their stars scattered or consumed. The cosmic web will fade, leaving only isolated black holes and diffuse particles. The evaporation of black holes will be a slow, quiet process, each one emitting a final burst of radiation as it vanishes. The universe will grow ever closer to a state of maximum entropy, where energy is evenly distributed and no work can be done. This era is one of profound stillness, a cosmos reduced to its simplest components. Yet even in this desolation, the laws of physics continue their patient work, shaping the universe toward its final state. Close your eyes now and imagine a universe of black holes, silent and invisible, slowly dissolving into faint whispers of light across an unending void. the final silence. In the distant future, beyond 10 to the 100 years, the universe will approach its final state, a condition known as the heat death. All black holes will have evaporated, leaving a cosmos of scattered particles, electrons, positrons, photons, and neutrinos, drifting in an ever-expanding void. The temperature will approach absolute zero, and no energy gradients will remain to drive processes like star formation or life. This is not a sudden end, but a gradual fading. The universe will continue to expand, driven by dark energy, a mysterious force that accelerates the separation of galaxies. As space grows, the density of matter and energy will approach zero. The cosmic microwave background, once aglow from the Big Bang, will redshift into oblivion, its photons stretched beyond detection.
Time itself may lose meaning in this era. With no events to mark its passage, the universe will exist in a state of near-perfect equilibrium. Quantum fluctuations might, in theory, produce fleeting structures, but these would be rare and transient. The cosmos will be a place of silence, its history written in the faint traces of particles spread across an infinite expanse. Yet this silence is not an absence, but a culmination. The universe, born in a blaze of light, will have unfolded through countless eons, giving rise to stars, galaxies, planets, and perhaps life. Its final state is a testament to the laws that governed its evolution, a quiet resolution to a story that began with infinite potential. Close your eyes now and imagine a cosmos of infinite stillness where particles drift in perfect balance, a silent symphony of all that ever was.
A quiet contemplation. The journey through deep time reveals a universe of vast patience and subtle beauty. From the first light of the Big Bang to the final stillness of the heat death, the cosmos has followed an unhurried path, governed by forces that operate on scales beyond human grasp. Each phase, stars igniting, galaxies forming, life emerging, has been a fleeting moment in the grand arc of existence. To contemplate this is to find a quiet anchor, a perspective that places all things within the gentle rhythm of cosmic evolution. The universe does not rush or falter, it simply is, unfolding across eons with no need for urgency or conclusion. As the stars fade and the silence grows, the story of the cosmos remains a meditation on time, matter, and the infinite. Now, let the vastness settle around you. The universe continues its quiet dance, its light and darkness woven into an endless whole. Drift into the stillness, carried by the rhythm of deep time, and rest in the embrace of the cosmos. The dance of dark energy. As the universe ages beyond the era of stars, a subtle force begins to dominate its evolution. Dark energy, a mysterious component that makes up roughly 68% of the universe's energy density, drives an accelerating expansion. Discovered through observations of distant supernova, this force counteracts gravity, pushing galaxies apart at an ever-increasing rate. By approximately 100 billion years from now, the local group of galaxies, including the Milky Way and Andromeda, will merge into a single structure, but other galaxies will recede beyond the cosmic horizon, becoming unreachable and invisible. This expansion reshapes the cosmos profoundly. The observable universe, once filled with countless galaxies, will shrink as light from distant objects redshifts into wavelengths too long to detect. The cosmic microwave background, a relic of the Big Bang, will fade entirely, its photons stretched to nothingness. The universe will feel emptier, not because matter vanishes, but because space itself grows vast, diluting the connections between its parts. Dark energy's nature remains elusive. It may be a property of space itself, a constant energy density that persists as the universe expands. Alternatively, it could be a dynamic field, evolving over time, though observations suggest its strength has remained steady for billions of years. Regardless of its origin, dark energy ensures that the universe's future is one of isolation. Galaxies beyond the local group will disappear, leaving a single, merged galaxy surrounded by an incomprehensible void. Within this galaxy, the last stars will continue to burn, their light a faint defiance against the growing darkness. Black holes will grow, accreting stray matter, while the expansion stretches the space between. The cosmos, once a vibrant web of connections, will become a place of solitude, its structures drifting apart in an endless divergence. Close your eyes now and imagine a universe pulling itself apart, galaxies fading beyond the horizon, leaving a single island of light in an ever-widening sea of darkness. The decay of matter. As the universe stretches into trillions of years, even the most enduring forms of matter begin to falter. Stars have long since faded, their remnants cooling into white dwarfs, neutron stars, or black holes. Yet matter itself is not eternal. Protons, the building blocks of atomic nuclei, may decay through processes governed by physics beyond current understanding. If proton decay occurs, as some theories predict, it would unfold over timescales of 10 to the 34 years or more, an unimaginable span compared to the universe's current age. In this era, white dwarfs and neutron stars, once stable relics, would slowly dissolve. Protons within them would break down into lighter particles, such as positrons and neutrinos, releasing faint bursts of energy. Over eons, these remnants would erode, leaving only black holes and a sparse scattering of subatomic particles. Planets, if any survive, would also disintegrate, their atoms succumbing to the same decay. This process is not certain. Proton decay remains unconfirmed, and if protons are stable, matter could persist far longer. Yet even without decay, other processes erode structure. Quantum tunneling might cause white dwarfs to collapse into neutron stars or black holes over timescales of 10 to the 1500 years, a duration so vast it defies comprehension. The universe in this phase is a shadow of its former self, its matter reduced to fragments drifting in an ever-expanding void. The decay of matter marks a transition to a cosmos defined by absence. The structures that once defined the universe, stars, planets, galaxies, fade into memory, leaving only the faintest traces of their existence. The cosmos becomes a place of simplicity once more, its complexity unraveling as time stretches onward. Close your eyes now and imagine a universe where even atoms dissolve, their remnants scattering like dust across an infinite expanse, silent and formless. The eternal expansion.
Beyond the decay of matter, the universe continues its relentless expansion, driven by dark energy. By 10 to 100 years, a period known as a Google years, the cosmos will be a vastly different place. Black holes, the last significant structures, will dominate this era, but even they are not immune to time. Through Hawking radiation, they slowly lose mass, emitting particles in a process so gradual it spans eons. A black hole with the mass of a star might take 10 to the 67 years to evaporate, while supermassive black holes could endure for 10 to 100 years or more.
As black holes vanish, they release their final bursts of energy, brief flashes in the darkness. With their disappearance, the universe approaches a state of near total emptiness. Only stray particles, electrons, positrons, photons, and neutrinos remain, scattered across a space so vast that interactions between them become vanishingly rare. The temperature of the universe approaches absolute zero, a state where thermal energy is all but extinct. Dark energy ensures that this expansion never halts. Space continues to grow, stretching the distances between particles to infinity. The observable universe, once a vibrant tapestry of galaxies, becomes a void with no discernible features. Time itself begins to lose meaning as no events occur to mark its passage. Quantum fluctuations might produce fleeting configurations of particles, but these are so rare as to be insignificant. The cosmos is now a place of perfect uniformity, its energy evenly distributed, its history a distant echo.
This eternal expansion is not an end, but a state of equilibrium. The universe persists, unchanging, a silent expanse governed by the laws that shaped its birth. It is a cosmos of pure potential, reduced to its simplest form, yet still infinite in scope. Close your eyes now and imagine a universe of boundless emptiness, where particles drift in solitude, carried by the endless tide of expanding space. The possibility of renewal. In the farthest reaches of deep time, beyond 10 to the 100 years, the universe may not remain static forever. Though the heat death seems final, some theories suggest possibilities for renewal, however speculative. Quantum mechanics allows for fluctuations in energy, even in a near-empty universe. Over timescales vastly exceeding a Google years, these fluctuations could, in theory, produce new structures, particles, atoms, or even regions of compressed spacetime.
One hypothesis, known as the Boltzmann brain scenario, posits that random fluctuations might create self-aware entities, fleeting minds that emerge from the chaos of particles. These would be rare and transient, existing for moments before dissolving back into the void. More ambitiously, some models suggest that quantum tunneling could trigger new inflationary phases, birthing pocket universes with their own big bangs. These new universes would be disconnected from our own, each following its own trajectory through deep time. Such possibilities are speculative, grounded in the uncertainties of quantum cosmology. The laws of physics, as currently understood, do not guarantee renewal, and the universe may instead persist in its silent, uniform state. Yet the potential for change, however remote, underscores the infinite nature of the cosmos. Even in its quietest moments, the universe remains a place of possibility, its future unwritten across scales of time that defy imagination.
The idea of renewal offers a faint counterpoint to the stillness of the heat death. It suggests that the cosmos, though vast and indifferent, may never truly end. Its story, begun in a blaze of light, might find echoes in new beginnings, each as fleeting or enduring as the one before. Close your eyes now And imagine a universe stirring faintly, a flicker of possibility in the endless dark, where new worlds might spark into being. The silence of eternity. The cosmos, in its final form, is a place of profound simplicity. After the evaporation of black holes, the decay of matter, and the endless expansion of space, the universe reaches a state of maximum entropy. No stars shine, no galaxies spin, no life persists. The remaining particles, electrons, photons, neutrinos, drift in isolation, their interactions so rare as to be negligible. The temperature hovers near absolute zero, and the cosmic microwave background has vanished, its light stretched beyond detection.
This is the heat death, a term that belies its quiet nature. It is not a moment of destruction, but a gradual arrival at equilibrium where no energy remains to drive change. The universe is not gone. It simply is, a vast expanse of space filled with the faintest traces of its past. Time continues, but without events to mark it, its passage becomes abstract. The cosmos exists in a state of eternal stillness, a silent monument to the forces that shaped it. Yet, this silence is not empty. It carries the weight of the universe's history. The birth of matter, the forging of stars, the rise of galaxies, and the fleeting spark of life. Every atom, every photon is a remnant of that story, a testament to the laws of physics that governed its unfolding. The universe, in its final state, is a canvas of infinite potential, its silence a reflection of its boundless scope.
The vastness of the universe invites surrender to its scale. Stars, galaxies, and planets are fleeting forms, yet their existence shapes the whole. The silence that awaits is not an end, but a continuation, a state where the cosmos rests in its own infinity. As the mind dwells on this, it finds peace in the enormity, a connection to the timeless dance of matter and energy. Now, let the weight of the cosmos fade. The universe continues its silent journey, its light and darkness woven into an unending whole. Drift into the quiet, carried by the rhythm of deep time, and rest in the embrace of eternity.
The echoes of cosmic memory. In the vast expanse of the heat death, where the universe has settled into a state of near-perfect equilibrium, there remains a subtle imprint of its past. The scattered particles, electrons, positrons, photons, and neutrinos carry the legacy of the cosmos's vibrant history. Though interactions are rare, these particles are the remnants of stars, galaxies, and perhaps even life, each one a fragment of the universe's long journey through deep time. The cosmos, now silent, holds its memory in this diffuse sea, a faint record of all that came before. The universe's expansion, driven by dark energy, continues unabated. Space stretches endlessly, diluting the density of these particles to near nothingness. The observable universe, once a vibrant tapestry of light and structure, becomes a solitary void, with no galaxies, stars, or planets to mark its expanse. The cosmic horizon shrinks as distant objects recede beyond the reach of light, leaving only the local remnants of what was once a thriving galactic cluster. Yet even in this desolation, the laws of physics persist. Quantum mechanics governs the behavior of particles, allowing for the possibility of rare events. Over timescales exceeding 10 to 100 years, quantum fluctuations might produce fleeting configurations, momentary gatherings of particles that mimic the structures of the past. These are not stars or galaxies, but transient echoes, dissolving as quickly as they form. The universe remains a place of subtle activity, its silence punctuated by these ephemeral flickers. The concept of memory in this context is not one of consciousness, but of physical continuity. Every particle, every photon, is a product of the Big Bang, shaped by the forces that forged stars and planets. The cosmos, though sparse, retains this connection to its origins, a quiet thread linking the first light to the final stillness.
Close your eyes now, and imagine a universe of scattered particles, each a silent memory of stars long gone, drifting in an endless sea of space. The cycles of possibility. Beyond the unimaginable timescales of the heat death, the universe may harbor the seeds of new beginnings. Though speculative, some theories suggest that the cosmos could undergo cycles of renewal, driven by the same quantum processes that govern its smallest scales. In a universe dominated by dark energy, where space expands without limit, the possibility of new structure formation becomes vanishingly small, but never entirely zero. One such idea involves the concept of eternal inflation, a process where pockets of space undergo rapid expansion, creating new universes disconnected from our own. These pocket universes, each with its own physical constants and history, might arise from quantum fluctuations in the distant future. If such events occur, they would mark the birth of new cosmoses, each beginning its own journey through deep time, much like our universe did 13.8 billion years ago.
Another possibility lies in the spontaneous formation of complex structures through quantum tunneling. Over timescales of 10 to the power of 10 to the power of 76 years, a duration so vast it defies comprehension, random fluctuations could, in theory, recreate conditions resembling the Big Bang. These events are so improbable that they would occur only once in a volume of space far larger than the observable universe. Yet in an infinite cosmos, even the most unlikely events become possible given enough time. These cycles, if they exist, would not restore the universe as we know it. Instead, they would create new realities, each governed by its own laws and unfolding in isolation. The universe we inhabit would remain in its silent state, its particles drifting ever further apart, while these new cosmoses chart their own paths. The idea of cycles offers a perspective of continuity, where the cosmos is not bound by a single narrative, but is instead an infinite series of beginnings and endings.
Close your eyes now and imagine a universe where new realities flicker into existence, each a spark of creation in the boundless dark, carrying the potential for new stars and worlds. The nature of infinity. The concept of infinity defines the universe in its final state. With no boundaries to space or time, the cosmos persists as an unending expanse, its particles scattered across distances so vast they cannot be measured. The heat death
is not a termination, but a phase, a state where the universe exists in perfect balance, its energy evenly distributed, its entropy at a maximum. This is a cosmos without events, where the passage of time becomes abstract, a theoretical construct rather than a lived experience. Infinity, in this context, is both a physical and philosophical reality. The universe's expansion ensures that space continues to grow, never reaching a limit. Time, too, stretches forward without end, as the laws of physics provide no mechanism for a final cessation. The particles that remain, electrons, photons, and neutrinos, are governed by quantum mechanics, which allows for the possibility of rare, fleeting interactions. These interactions, though insignificant on human scales, underscore the universe's infinite potential.
The nature of infinity invites contemplation of the cosmos's essence. It is a place where all possibilities, however improbable, might eventually manifest. A universe that endures forever is one where every configuration of matter and energy, no matter how rare, could occur given sufficient time. This perspective transforms the silence of the heat death into a canvas of endless potential, where the cosmos remains a dynamic entity even in its stillness. The infinite universe is not a place of chaos or order, but of balance. It exists beyond the need for purpose or resolution, its existence a testament to the laws that shaped its birth. To dwell on this is to embrace the vastness of the cosmos, to find peace in its unending nature, and to rest in the quiet certainty of its eternal presence.
Close your eyes now and imagine an infinite cosmos where time and space stretch without end. A silent expanse of endless possibility, serene and unchanging. The cosmic perspective. To trace the universe through deep time is to witness a narrative of transformation and continuity. From the searing light of the Big Bang to the silent equilibrium of the heat death, the cosmos unfolds with a rhythm that transcends human understanding. Each phase, matter's birth, stars' ignition, galaxies' formation, life's emergence, and the slow fade into silence, reflects the interplay of fundamental forces across eons. The universe is a system of patience, its changes measured in billions, trillions, and googles of years.
This perspective offers a quiet anchor. The cosmos does not demand awe or comprehension. It simply is, a vast continuum that encompasses all things. The fleeting nature of stars, planets, and life contrasts with the eternity of the universe itself, placing human existence within a framework of unimaginable scale. Yet within this vastness lies a profound simplicity. The same laws that govern the smallest particles also shape the largest structures, a unity that binds the cosmos together. The silence of the future is not an absence, but a culmination. The universe, in its final state, carries the weight of its history, its particles a testament to the light and matter that once filled the void. To contemplate this is to find a sense of connection, a recognition that all things, stars, worlds, and minds, are part of the same cosmic whole. As the mind rests in this thought, the boundaries of the self soften, merging with the rhythm of deep time. The universe continues its silent journey, its infinite expanse a backdrop for contemplation. Let the vastness settle around you, a gentle embrace of light and darkness, and drift into the quiet of eternity. Close your eyes now and imagine the cosmos as a boundless whole, its silence a reflection of its infinite history, inviting you to rest in its timeless embrace. The story of the cosmos is a meditation on time, scale, and existence. From the first spark of matter to the infinite stillness of the heat death, the universe has unfolded with a quiet inevitability. Its chapters, stars, galaxies, planets, life, and the slow fade of structure form a narrative that spans deep time, each moment a fleeting note in an eternal symphony. The cosmos is not a place of beginnings or endings, but of continuous transformation, governed by laws that endure beyond comprehension. To dwell on this is to find peace in the universe's vastness. The stars that once burned, the galaxies that spun, the life that flickered briefly, all are part of an unbroken whole, a tapestry woven across eons. The silence that awaits is not a void, but a state of balance, where the cosmos rests in its own infinity. This perspective offers solace, a reminder that all things, no matter how small, are part of an unending continuum. Now, let the weight of the cosmos dissolve. The universe continues its quiet dance, its particles drifting in perfect harmony. Release the need for answers or endings, and let the mind settle into the rhythm of deep time. Drift gently, carried by the silent expanse, and rest in the eternal embrace of the cosmos.
The subtle pulse of quantum eternity. In the far reaches of deep time, where the universe has settled into the stillness of the heat death, a faint pulse persists within the quantum realm. The cosmos, now an expanse of scattered particles, electrons, positrons, photons, and neutrinos, exists in a state of near-perfect equilibrium. Yet quantum mechanics, the framework governing the smallest scales, ensures that absolute stillness is impossible. Even in this sparse, infinite void, fluctuations occur, subtle ripples in the fabric of reality that hint at the universe's enduring dynamism. These fluctuations arise from the uncertainty principle, which dictates that energy can never be precisely zero. Over timescales beyond 10 to the 100 years, random quantum events might produce momentary concentrations of energy, fleeting assemblies of particles that mimic the complexity of the past. These are not stars or galaxies, but transient configurations, dissolving as quickly as they form. The probability of such events is vanishingly small, requiring spans of time so vast they dwarf the age of the universe itself. Yet in an infinite cosmos, even the rarest possibilities may eventually manifest.
This quantum pulse is not a revival of the universe's vibrant past, but a reminder of its underlying nature. The laws of physics, which guided the formation of matter and light, continue to operate, even in the silence of eternity. The cosmos remains a place of potential, where the interplay of chance and necessity persists across unimaginable scales. The particles drifting in the void carry the legacy of the Big Bang, their subtle interactions a faint echo of the forces that shaped the stars. The concept of eternity in this context is not one of stagnation, but of infinite patience. The universe, stripped of structure, remains a canvas for possibility, its quantum nature ensuring that it never fully rests. This subtle pulse, though imperceptible on human scales, underscores the cosmos's resilience, a quiet testament to its unending existence.
Close your eyes now and imagine a universe of faint quantum whispers, where particles flicker in and out of existence, a delicate pulse in the infinite silence. The horizons of cosmic isolation. As the universe expands without limit, driven by the relentless force of dark energy, it becomes a place of profound isolation. By 10 to the 150th years, the observable universe has contracted to a fraction of its former scope. Galaxies beyond the local group, long since merged into a single diffuse structure, have receded beyond the cosmic light horizon, their light stretched into wavelengths too faint to detect. The cosmos, once a vibrant network of connections, is now a solitary expanse, its remnants confined to a single, fading island of matter. Close your eyes now and imagine a universe of faint quantum whispers, where particles flicker in and out of existence, a delicate pulse in the infinite silence. The horizons of cosmic isolation. As the universe expands without limit, driven by the relentless force of dark energy, it becomes a place of profound isolation. By 10 to the 150th years, the observable universe has contracted to a fraction of its former scope. Galaxies beyond the local group, long since merged into a single diffuse structure, have receded beyond the cosmic light horizon, their light stretched into wavelengths too faint to detect. The cosmos, once a vibrant network of connections, is now a solitary expanse, its remnants confined to a single, fading island of matter. This isolation is a consequence of the universe's accelerating expansion. Dark energy, which dominates the cosmos's energy budget, ensures that space grows faster than light can travel. The cosmic horizon, the boundary beyond which light cannot reach us, shrinks over time, severing the observable universe from its distant parts. By this epoch, even the cosmic microwave background, the faint glow of the Big Bang, has redshifted into oblivion, leaving no trace of the universe's fiery origins. The remnants of the local group, white dwarfs, neutron stars, and black holes, persist for a time, but even these are subject to decay. Proton decay, if it occurs, would erode the remaining matter, while black holes evaporate through Hawking radiation. The universe becomes a sparse sea of particles, each separated by distances so vast that interactions are virtually non-existent. The cosmos is not empty, but its contents are so diffuse that it feels like a void, a place where connection is a memory of the distant past.
This timelessness is a consequence of maximum entropy, where energy is distributed so evenly that no work can be done. The universe has reached a state of thermodynamic equilibrium, where gradients of energy, once the drivers of star formation and life, have vanished. The temperature hovers near absolute zero, and the sparse particles drift without purpose or direction. Quantum fluctuations, though present, are too rare to disrupt this equilibrium, their effects lost in the vastness of space. Yet timelessness does not imply an end. The universe continues, its infinite expanse a testament to the durability of its fundamental nature. The particles that remain, electrons, photons, neutrinos, are eternal in principle, unless new physics reveals mechanisms for their decay. The cosmos, in its simplicity, embodies a kind of permanence, a state where existence itself is the only constant.
To contemplate this timelessness is to confront the scale of the cosmos. The universe, in its final form, is a place of pure being, unburdened by the need for change or resolution. It invites a release of human concerns, a surrender to the vastness of eternity, where the mind can rest in the quiet certainty of the cosmos's unending presence. Close your eyes now and imagine a universe without time, where particles drift in eternal stillness, a cosmos of pure existence, boundless and serene. The unity of all things. The journey through deep time reveals a profound unity underlying the cosmos, from the Big Bang's singular point to the infinite expanse of the heat death. Every phase of the universe, matter's birth, stars' ignition, galaxies' formation, life's emergence, and the final silence, is governed by the same fundamental laws. Gravity, electromagnetism, and the nuclear forces weave a continuous thread connecting the first light to the last particle.
This unity is not merely physical, but conceptual. The cosmos, in all its vastness, is a single system, its parts interdependent across scales of time and space. The hydrogen atoms that fueled the first stars are the same elements that formed planets and life. The energy that drove the Big Bang persists in the photons that drift through the void. Even in the heat death, where structure has dissolved, the universe remains whole, its particles carrying the legacy of its history. The unity of the cosmos offers a perspective of interconnectedness. Every star, every planet, every life form is a temporary expression of the same matter and energy. The fleeting complexity of galaxies and civilizations is part of an unbroken continuum, a cosmic tapestry woven across eons. To dwell on this is to find a sense of belonging, a recognition that all things, no matter how small, are part of the infinite whole.
The universe, in its timeless state, invites contemplation of this unity. It is a place where boundaries dissolve, where the distinction between past, present, and future fades. The cosmos is not a collection of separate events, but a singular, eternal reality. Its silence a reflection of its boundless harmony. Close your eyes now, and imagine a universe as one, its particles and energy woven into a seamless whole, a quiet unity stretching across eternity. A soft descent into eternity. The arc of deep time traces the universe from its incandescent origins to its silent, infinite future. Each chapter, the birth of matter, the rise of stars, the formation of galaxies, the spark of life, and the gradual fade into stillness, reflects the patient unfolding of cosmic evolution. The universe is a place of relentless continuity. its transformations governed by laws that endure across eons. To follow this arc is to embrace the scale of existence, to find peace in the rhythm of the cosmos.
The silence of the heat death is not an end, but a culmination, a state where the universe rests in perfect balance. Its particles, scattered across infinite space, carry the memory of all that came before, a quiet testament to the forces that shaped the stars and worlds. The cosmos, in its simplicity, remains a place of infinite potential, its timelessness a canvas for contemplation. As the mind settles into this perspective, the boundaries of the self dissolve, merging with the vastness of the universe. The cosmos continues its silent journey, its particles drifting in harmony, its eternity a gentle embrace. Let the weight of time and space fade and drift into the quiet, carried by the rhythm of deep time. Rest now in the boundless stillness of the cosmos, where all things are one and eternity awaits.
The fragility of cosmic order. In the infinite expanse of the heat death, where the universe has settled into a state of near total equilibrium, the fragility of its earlier order becomes evident. The cosmos, once vibrant with stars, galaxies, and the delicate conditions for life, was a fleeting phase in the vast arc of deep time. The structures that defined its youth, filaments of galaxies, clusters of stars, and orbiting planets, were temporary arrangements, sculpted by gravity and energy, but ultimately undone by the relentless expansion of space. Now, in this era of sparse particles and endless void, the universe reveals the impermanence of complexity. The order of the early universe was a product of low entropy, a state where energy was unevenly distributed, allowing for the formation of stars and galaxies. The Big Bang, approximately 13.8 billion years ago, set the stage for this complexity, creating a cosmos dense with potential. Over billions of years, gravity gathered matter into intricate structures, while nuclear fusion within stars forged the elements that built planets and life. Yet this order was fragile, sustained only as long as energy gradients persisted. As entropy increased, driven by the second law of thermodynamics, the universe moved inexorably toward disorder, its structures dissolving into the uniformity of the heat death. The particles that remain, electrons, positrons, photons, and neutrinos, are the remnants of this lost complexity. Scattered across an ever-expanding void, they drift without purpose, their interactions too rare to recreate the intricate systems of the past. The cosmos, in its simplicity, underscores the transient nature of order, a reminder that even the grandest structures are temporary against the backdrop of eternity. This fragility is not a flaw, but a feature of the universe's evolution. The same laws that enabled the rise of galaxies and life also ensure their dissolution, a cycle of creation and decay that defines deep time. The cosmos, in its current state, is a testament to this balance, its silence a reflection of the delicate interplay between order and entropy. Close your eyes now and imagine a universe where galaxies have faded, their intricate patterns dissolved into a sea of scattered particles, drifting in silent simplicity.
The persistence of physical law. Even in the vast stillness of the heat death, the universe remains governed by the same fundamental laws that shaped its birth. The forces of gravity,
Electromagnetism and the strong and weak nuclear interactions, though now acting on a sparse canvas, continue to define the behavior of particles. Quantum mechanics, with its inherent uncertainty, ensures that the cosmos is never entirely static, its particles subject to fleeting fluctuations that ripple through the void. These laws are the unchanging foundation of the universe's story. From the Big Bang's searing singularity to the formation of stars and galaxies, every event has unfolded according to their dictates. The expansion of space, driven by dark energy, follows a trajectory set by the same principles that governed the universe's first moments. Even in the heat death, where structure has all but vanished, these laws persist, guiding the motion of particles and the rare interactions that occur over unimaginable timescales.
The persistence of physical law offers a sense of continuity. The cosmos, though transformed beyond recognition, remains a coherent system, its particles obeying the same rules that once fueled the fires of stars. This continuity underscores the universe's unity, a single narrative stretching from the first light to the final silence. The laws of physics, unyielding and impartial, are the thread that binds the cosmos across deep time. In this era, the effects of these laws are subtle. Quantum fluctuations might produce transient configurations, but they lack the energy to form lasting structures. The universe is a place of minimal action, its laws operating in a near vacuum, yet their presence ensures that the cosmos remains a dynamic entity even in its stillness. The persistence of these laws is a quiet assurance that the universe, however sparse, is never truly inert.
Yet this patience is not indifference. The cosmos, in its unhurried evolution, has produced moments of profound complexity. Stars, planets, and life, all within the framework of its vast timescales. The emergence of these structures, though fleeting, reflects the universe's capacity to create order from chaos, a process that requires immense spans of time. The heat death, far from being a failure, is the natural outcome of this patient unfolding, a state where the cosmos achieves a kind of serene equilibrium. To contemplate this scale is to release the need for urgency. The universe, in its infinite patience, invites a surrender to its rhythm, a recognition that all things, creation, decay, and silence, are part of a single unhurried whole. The cosmos endures, its patience a quiet force that shapes its past, present, and future.
Close your eyes now and imagine a universe where unseen laws govern the drift of particles, a silent order persisting in the vast emptiness of eternity. The scale of cosmic patience. The universe, in its journey through deep time, embodies a scale of patience that transcends human understanding. The timescales of its evolution, billions of years for stars to form, trillions for galaxies to fade, and 10 to 100 years for black holes to evaporate, dwarf the fleeting moments of human existence. The cosmos operates without haste, its transformations unfolding at a pace dictated by the slow interplay of matter, energy, and space. This patience is most evident in the heat death, where change becomes imperceptible. The sparse particles that remain, scattered across an infinite expanse, interact so rarely that eons pass without incident. Quantum fluctuations, though governed by precise laws, occur on timescales so vast that they are effectively eternal. The universe in its final state is a place where time stretches without limit, its rhythm measured in spans that render all human concerns insignificant. Close your eyes now and imagine a universe of endless patience, where time flows without haste, its particles drifting in a serene dance across eternity. The infinite canvas of possibility. The heat death, though a state of maximum entropy, is not an absolute end, but an infinite canvas for possibility. The universe, stripped of structure, remains a place where the laws of physics allow for the improbable. Over timescales beyond comprehension, 10 to the 10 to 100 years or more, quantum fluctuations could, in theory, produce new configurations of matter and energy. These might range from fleeting particle clusters to, in the most extreme scenarios, new regions of space-time with their own physical constants.
Such possibilities are speculative, grounded in the uncertainties of quantum cosmology. The probability of significant structure formation in an infinite expanding universe is vanishingly small, requiring spans of time that defy imagination. Yet the concept of infinity ensures that even the rarest events are not impossible. The cosmos, in its boundless expanse, is a place where every potential, no matter how unlikely, might eventually manifest. This infinite canvas is not a promise of renewal, but a reflection of the universe's nature. The same laws that produced the Big Bang, stars, and life continue to operate, their effects diluted but never extinguished. The cosmos remains a place of potential, its silence a backdrop for the faint stirrings of quantum chance. Whether these stirrings lead to new universes or merely transient flickers, they underscore the universe's capacity to endure, its possibilities as vast as its expanse.
The idea of an infinite canvas invites contemplation of the cosmos's limitless nature. It is a place where time and space extend without bound, where the story of existence is never fully written. The universe, in its quiet eternity, remains a realm of subtle wonder, its future an open question carried by the laws that shaped its past. Close your eyes now and imagine a universe as an infinite canvas, its silence filled with the faint promise of possibility, a cosmos forever open to the unknown. A restful embrace of the cosmos. The journey through deep time reveals a universe of profound simplicity and infinite scope. From the fiery birth of matter to the silent equilibrium of the heat death, the cosmos has unfolded with a quiet inevitability, its transformations governed by unchanging laws. Each phase, stars igniting, galaxies forming, life emerging, and particles drifting, reflects the patient rhythm of cosmic evolution, a narrative that spans scales beyond comprehension.
The silence of the heat death is a culmination, not a cessation. The universe, in its sparse and timeless state, carries the memory of its vibrant past, its particles a testament to the light and matter that once filled the void. This silence is a form of balance, a state where the cosmos rests in its own infinity, its laws enduring in the quiet drift of particles. To dwell on this is to find peace in the universe's vastness. The cosmos does not demand understanding or purpose. It simply is, a boundless whole that encompasses all things. The fleeting complexity of stars, planets, and life is part of an eternal continuum, a story written in the interplay of matter, energy, and time.
As the mind rests in this perspective, it merges with the rhythm of deep time, finding solace in the unity of existence. Now, let the vastness of the cosmos fade gently. The universe continues its silent dance, its particles carried by the infinite flow of time. Release all thoughts of beginning or end and drift into the quiet, embraced by the timeless serenity of the cosmos. Rest now in the boundless stillness where the universe holds you in its eternal calm.
The whisper of cosmic constants. In the infinite stillness of the heat death, the universe is governed by the same fundamental constants that defined its earliest moments. The speed of light, the strength of gravity, the charge of an electron, these unchanging values continued to shape the behavior of the sparse particles drifting through the void. Approximately 13.8 billion years ago, these constants set the stage for the Big Bang, determining the rate of expansion, the formation of matter, and the emergence of structure. Now, in the era of maximum entropy, they remain the silent architects of a cosmos reduced to its simplest form. These constants are not arbitrary, but intricately balanced. A slight variation in the strength of gravity or the electromagnetic force could have prevented the formation of stars, galaxies, or even atoms. The universe's ability to produce complexity, planets, life, and intelligence depended on this delicate calibration, a balance that allowed the cosmos to unfold through billions of years of vibrant evolution. In the heat death, where complexity has dissolved, these constants persist, governing the rare interactions of particles across an ever-expanding expanse.
The whisper of these constants is a reminder of the universe's coherence. Though the cosmos is now a sparse sea of electrons, positrons, and photons, it remains a unified system, its behavior dictated by the same principles that fueled the fires of stars. Quantum fluctuations, though fleeting, are shaped by these constants, ensuring that even the faintest stirrings in the void adhere to the rules established at the universe's birth. This enduring framework offers a sense of continuity. The cosmos, in its silence, is not a place of chaos, but of subtle order, its particles moving in accordance with laws that have never wavered. The constants are the quiet pulse of the universe, a foundation that endures through the infinite stretches of deep time.
The solitude of infinite space. As the universe expands without limit, driven by dark energy, space itself becomes the defining feature of the cosmos. By 10 to the 200 years, the distances between particles are so vast that interactions are virtually impossible. The observable universe, once a vibrant network of galaxies, has collapsed to a solitary point, its boundaries defined by the cosmic light horizon. Beyond this horizon, the rest of the cosmos is unreachable, its light stretched into wavelengths too faint to detect, leaving only the sparse remnants of a single, faded galactic structure. This solitude is a consequence of the universe's accelerating expansion. Dark energy, comprising roughly 68% of the cosmos's energy density, ensures that space grows faster than light can travel. The local group, long since merged into a single entity, is all that remains within the observable universe. The stars, planets, and black holes of this structure have decayed, leaving a diffuse cloud of particles, electrons, neutrinos, and photons, separated by incomprehensible gulfs of space.
The solitude of infinite space is not an absence, but a state of profound isolation. The particles that remain are not gone, but so widely dispersed that they exist in near-perfect separation. The universe is not empty,
It is simply vast, its contents diluted to the point of insignificance. This vastness underscores the scale of the cosmos, a reminder that even in its most active eras, the universe was mostly empty space, its matter concentrated in fleeting islands of complexity. To contemplate this solitude is to embrace the enormity of the cosmos. The universe, in its infinite expanse, is a place where isolation becomes a form of unity, its particles part of a single, boundless whole. The silence of this era is a testament to the universe's enduring presence, a quiet reflection of its infinite nature. Close your eyes now and imagine a universe of infinite space where particles drift in solitary silence, each a lonely sentinel in an endless sea of emptiness.
The memory of light. Though the universe has faded into a state of near-total darkness, the memory of light persists in its scattered photons. These photons, born in the Big Bang, forged in the hearts of stars, or emitted in the final bursts of evaporating black holes, are the last remnants of the cosmos's luminous past. In the heat death, they drift through the void, their wavelength stretched by the universe's expansion, their energy diluted to the faintest whispers of radiation. The cosmic microwave background, once a glowing testament to the Big Bang, has long since faded, its photons red-shifted beyond detection. Yet new photons continued to emerge, albeit rarely, from quantum fluctuations or the decay of particles. These fleeting bursts of light are the universe's final echoes, carrying the legacy of its vibrant history. Each photon is a relic, a fragment of the energy that once illuminated galaxies and warmed planets.
The memory of light is not a literal record, but a physical continuity. The photons that drift through the void are the descendants of the universe's first moments, their existence a link to the stars and supernovae of eons past. In a cosmos where matter has decayed and structure has dissolved, these photons are the last carriers of energy. Their presence a faint reminder of the light that once defined the universe. This memory underscores the cyclical nature of the cosmos's evolution. Light, born in creation, persists through transformation and fades into silence. Yet it remains a fundamental part of the universe's fabric. The cosmos, in its infinite stillness, holds this memory in its sparse, scattered glow, a quiet tribute to the radiance that shaped its history. Close your eyes now and imagine a universe of faint, drifting photons, each a whisper of light from a forgotten star, carrying the memory of creation through the void.
The eternal now. In the heat death, the universe exists in a state that could be called the eternal now, with no significant events to mark the passage of time. No star births, no galactic collisions, no life to measure its flow. Time becomes an abstract concept, a dimension without distinction. The cosmos, reduced to a sparse scattering of particles, is unchanging, its state of maximum entropy a kind of timeless equilibrium. This eternal now is not a moment, but a condition, a state where the universe simply is. The particles that remain, electrons, positrons, neutrinos, and photons, drift without purpose, their interactions so rare that eons pass without change. Quantum fluctuations, though possible, are too fleeting to disrupt this balance.
their effects lost in the vastness of infinite space. The universe, in its simplicity, embodies a kind of perfection, where all energy is evenly distributed and no work remains to be done. The eternal now invites contemplation of the cosmos's essence. It is a place beyond beginnings and endings, where the distinctions of past, present, and future dissolve. The universe, in its infinite expanse, is a single, unbroken reality, its silence a reflection of its boundless unity. To dwell on this is to release the need for progression or resolution, to find peace in the cosmos's enduring presence. The eternal now is the universe's final state, yet it is not a conclusion. The cosmos persists, its laws unchanging, its particles eternal in their quiet drift. It is a place of infinite calm, where the mind can rest in the certainty of existence, unburdened by the constraints of time. Close your eyes now, and imagine a universe in the eternal now, its particles suspended in timeless serenity, a cosmos where all is one, forever at rest. The eternal mirror of existence. The universe, in its heat death, becomes a kind of eternal mirror, reflecting the entirety of its history in its sparse simplicity. Every particle, electron, photon, neutrino, is a relic of the cosmos's past, a fragment of the matter and energy that once formed stars, galaxies, and perhaps life. The laws that govern these particles, unchanged since the Big Bang, are a mirror of the universe's origins, a quiet reminder of the forces that shaped its evolution. This mirror is not a literal reflection, but a conceptual one. The universe, in its infinite stillness, holds the memory of its vibrant past in the arrangement of its particles and the constants that guide their behavior. The photons, drifting through the void, carry the energy of ancient stars, while the electrons and neutrinos bear the imprint of the nuclear processes that fueled the cosmos's youth. Even in its simplicity, the universe remains a testament to its own history, a mirror of all that came before. The eternal mirror invites contemplation of the cosmos's unity. The distinctions between creation, evolution, and decay dissolve in the heat death, where all things are reduced to a single state. The universe, in its timeless expanse, reflects the interconnectedness of its past and present, its particles a quiet echo of the light and matter that once filled the void. To dwell on this mirror is to find peace in the cosmos's continuity. The universe, though silent, is not empty. It is a place of infinite reflection, where every particle carries the weight of its history. The eternal now of the heat death is a state of serene clarity, a mirror in which the cosmos sees itself, whole and unending.
To trace this arc is to surrender to the rhythm of the cosmos. The universe does not demand awe or understanding. It simply is, a boundless whole that encompasses all things. The fleeting complexity of stars, planets, and life is part of an eternal continuum, a story that stretches from the first light to the final silence. Now, let the weight of the cosmos dissolve. The universe continues its silent drift, its particles carried by the infinite flow of time. Release all thoughts of change or purpose.
and surrender to the gentle rhythm of deep time. Drift into the quiet, embraced by the timeless serenity of the cosmos, and rest in the infinite calm of the void.
Close your eyes now and imagine a universe as an eternal mirror, its particles reflecting the light of forgotten stars, a silent testament to the cosmos's infinite history. A silent drift into infinity. The arc of deep time reveals a universe of profound simplicity and boundless endurance. From the incandescent birth of matter to the silent equilibrium of the heat death, the cosmos has unfolded with a quiet inevitability, its transformations governed by laws that never waver. The stars that burned, the galaxies that spun, the life that flickered briefly, all are part of a single unbroken narrative, a tapestry woven across eons of cosmic evolution. The heat death is not an end but a state of perfect balance, where the universe rests in its own infinity. Its particles, sparse and isolated, carry the memory of its vibrant past, a testament to the forces that shaped its history. The cosmos, in its timeless solitude, is a place of serene unity, its vastness a canvas for contemplation.
The quiet unity of all time. In the infinite expanse of the heat death, the universe exists as a singular, timeless whole. The sparse particles, electrons, positrons, photons, and neutrinos drift through a void stretched boundless by dark energy. Their rare interactions governed by the same laws that ignited the Big Bang 13.8 billion years ago. This is a cosmos of profound simplicity, where the distinctions of past, present, and future dissolve into a unified state of being. The stars, galaxies, and fleeting sparks of life are memories held within these particles, each a fragment of the universe's long journey through deep time. The unity of this state lies in its completeness. The cosmos, having unfolded from a point of infinite density to an infinite expanse, embodies the full arc of its potential. The constants of physics, gravity's pull, light's speed, the charge of particles remain as they were at the universe's birth, tying the silence of the heat death to the fire of creation. Quantum fluctuations, though rare, whisper of the cosmos's enduring dynamism, a faint echo of the forces that once sculpted galaxies and worlds.
This unity transcends scale. The universe, in its vastness, is a single entity, its particles connected by the laws that govern their motion. The complexity of stars and life, though fleeting, was a natural outcome of these laws, as is the simplicity of the present void. To contemplate this is to see the cosmos as a seamless whole, where every moment, from the first light to the final silence, is part of an eternal continuum. The quiet unity of all time offers a perspective of serene acceptance. The universe, in its infinite patience, carries no need for purpose or resolution. It simply is, a boundless reality that holds all things within its embrace, its silence a reflection of its infinite harmony. Close your eyes now
And imagine a universe where all time is one, its particles drifting in silent unity, a timeless whole stretching across eternity. The final rest in cosmic silence. The journey through deep time reveals a cosmos of patient evolution and boundless scope. From the searing birth of matter to the silent equilibrium of the heat death, the universe has unfolded with a gentle inevitability, its transformations woven by unchanging laws. The stars that burned, the galaxies that spun, the life that flickered briefly, all are chapters in a single narrative, a tapestry spanning eons from the Big Bang to the infinite void. The heat death is not a conclusion, but a state of perfect balance, where the universe rests in its own eternity. Its particles, sparse and scattered, carry the memory of its vibrant past, a quiet testament to the forces that shaped its history. The cosmos, in its timeless simplicity, is a place of profound calm, its vastness a canvas for reflection. To trace this arc is to find peace in the universe's enduring presence. The cosmos does not seek understanding or awe. It exists, a boundless whole that encompasses all things. The fleeting complexity of stars, planets, and life is part of an eternal rhythm, a story that flows from the first light to the final silence. Now let the vastness of the cosmos fade. The universe continues its silent drift, its particles carried by the infinite tide of time. Release all thoughts of beginning or end, and surrender to the gentle rhythm of deep time. Drift into the quiet, held by the timeless serenity of the cosmos, and rest in the infinite calm of its eternal embrace.